I'd love to say happy Friday, but I don't know if you guys are as stressed out as I am over this COVID-19 and the stock market crash. So I'm going to be going off the air for a while. I need to pay attention to things that are going on, helping neighbors. There are a lot of people. It's raining like crazy. Some neighbors have roof leaks, all kinds of stuff, and I need to be watching the stock market constantly here. So this video isn't much because I've been paying attention to other things. Not much machining, but it's just a little bit of insight what I did with the Universal Tool Grinder, aka D-bit grinder, or U2. So I hope you enjoy it, and I hope everybody stays okay through all of this. You know, we've got some 80 cases here now. Thank God no deaths, but quite a few people are hospitalized. But last couple of days we wound up with 20 more cases of it. So let's see what happens. Good luck to everybody. Catch you when I can. Like I said, if you're looking forward to seeing machining, this video is not for you. If you don't own a U2, aka D-bit grinder, Universal Tool Grinder, this video is also not for you. But hopefully this might inspire you to look at some machine you have and improve it. Like anything from China or even some other places, there's always room for improvement. So you saw in the last video the sticking problem I was having trying to make a chamfer tool here. So let me talk about this part first. This is the bottom piece that everything slides into the wheel with. I started looking at it going, you know, why is everything sloppy? You can't get it so things don't rock. Why is it jamming? So first I wound up lapping this surface right here. It's now like glass. It's beautiful. And I took some 1.5 micron diamond paste and put it in here and ran this guy back and forth on it. And I know you can't see what happened, but yeah, it had a lot of ripples to it, and that was part of the problem. So it's really smooth now, and I also lapped the gib, put everything back together with this guy and also the 5C holder thing that goes on there. Perfect, got it fixed. Also turned out the 5C holder had like a burr right at the corner, which was causing the problem. So I took a file, got rid of that. So this now is all perfect. I got things fixed, I got things stable, but it still doesn't solve the problem where I'm trying to get like this guy on the center of the wheel so that this face is square and not at an angle like that. So now let me talk about this part. I did some calculations, figured out that a 10-degree tilt should put this guy on center of the wheel and probably help with a bunch of other parts, like when I'm using that. No, I have the other adapter for it, but when I'm trying to make a lathe cutting tool or something, I'll be now more on the center of the wheel. So long story short, I started banging this thing out. I started on this side, do that, do the dovetail. Then I flipped it and started drilling this hole. Turns out I grabbed the wrong drill bit. It was oversized, so you can see here. I had to make little brass bushings, press them in both sides. Long story short, I mean, this was 4 days of work, and the last hole I had to do was this one, and it was off. So I learned real quick. This part is so complicated that you need to focus on one thing at a time per day. So I made another one. I'll take you over here and show you it on the machine. But there's so much room. It's so easy to make a mistake if you just keep going at this. So I started working one thing at a time, completely focusing on it, and then doing that, and then quit for the day. So this was one day. I forgot what I did. I think the next day was just trying to figure this out. The other thing is I was just working on scratch paper. You know, I didn't truly formally draw it up and build it to that. So I'm playing with scratch paper, trying to figure out where these holes are. Very complicated because it has to match the gib and the dents in the gib perfectly. So now, after messing a bunch of stuff up, I formally did this first, measuring this guy as carefully as I could. This hole I actually put in the mill, and my error was I was from this edge to the center, and you should have done it from the center here to there, because this edge can move, and that causes a problem, because it's like you got to be within a few thousandths for it to work right. So I used a gauge pin. I found edge finder, found the dead center, gauge pin, found that number, and I spent 2 hours, because no matter how you double check it, it was off, and I'm going, it can't be off. But I finally got it figured out, and the one that I did make is right on the money. So this was a nightmare. The other problem I was having was trying to hold this thing solid. So I had made this guy 10 degrees, and it was doing a pretty good job, but I was thinking, you know, if I'm going to go through all this trouble again, I don't want it moving. So I made a nice big 10 degree that held everything rock solid. So that was another kind of learning curve for me in that. What else can I say? So I've got it all documented, everything, you know, like I said, one day at a time. Okay, I'm going to do these holes today, double check the print, double check this guy, everything, and double check this part because it did line up, and then drill the holes on the new part. Actually, I didn't screw this hole up on the new part too, because that was, you know, I think this, no, I did do this and that hole the same day, so whatever. This was also another very complicated hole to do, because you center it up between here so that you're on center, drill straight down through with the one size under, like I said I always do, and then the actual drill bit, and then you got to come in with the end mill. I think it was a 10 millimeter something. No, that's a 12, whatever. I've got it here. Oh, it's a 25/64 hole and a 10 millimeter end mill to do the slot, and you go down, you know, quite a bit. But same way, the print was hard to do. This is my third print, and because I realized, look, just draw each face, you know, and write the dimensions on them. So once I got that idea, this came out really good. So not much else I can say. The new part works fantastic. I was able to make this chamfer tool in a few minutes. Beautiful. I didn't even have to hone it. It's super sharp. That edge is straight, not at an angle. So this stays on the machine. One thing I did realize, though, as a kick, I'm at 10 degrees. So when I say 0 degrees on tilt, I'm actually 10 degrees, not 0. So I got to go minus 10 degrees before this thing will be flat into the wheel. But so I'll take you over to the machine and show you the final part here. Apologize for the lighting. It's probably not that good, but the freezing cold outside, so it's not even sunny, so it's no matter opening up the garage door. final part. I don't know what to say. I'm thrilled to death with it. I guess you can see all. Let me lock this thing. So, I don't know. Look in the camera. Yeah, you can kind of see that side. Works beautifully. It doesn't take much to lock the gib up or unlock it. I've got a real short guy in here. This in there. So yeah, this is the one I used to make that one chamfer tool, and there is no play in this thing at. Lock this. No play in this thing at all. I mean, it's just beautiful. This one too, I can lock easily. It's not moving. Do I have a collet? No. So that one, yeah, that bit was actually, I think that was regular drill rod. So I had to change the wheel out. This one's for just regular steel. There's a different one for high-speed steel that was on it. Or maybe that one was. Yeah, I think that one was the high-speed steel. I changed this wheel out because I had to make another set of knobs. By the way, this machine is really beautiful for making cones, if you want to call it that. Get this thing out. It's done in the blink of an eye. As I drop it, it's done in a blink of an eye. Really easy, comes out nice and beautiful. So what else? There's not much else I can really say on this other than I'm looking forward to there, bottoms out. Really looking forward to using this for other things. I did use my trick of non-permanent Loctite on the threads for the Gibbs screws. Once it's set up, you can easily tweak them and they stay put, so you don't even really need these nuts on here. I just finger tighten them. I'm probably going to have to just slightly hit them with a wrench because they're going to keep moving around. Did realize too, I mean, you can see this is pretty much so falling. Wrong way. Oh, I got to pull this pin and go that way. It's kind of falling on center with the wheel now, which is what I was aiming for doing this whole project. And I realized too, if there is no adjustment for this, as I was saying, you know, I realize I'm at 10 degrees, so I got to go minus 10. There isn't nothing to go minus 10 with. So if I want it flat, I'm going to have to change the base out. No big deal. And I think when I put the other part in, by luck, the Gibbs are at the right spot. So it's just as tight, but don't quote me on that. So I'm really thrilled with this machine. You know, I can do this stuff, whereas the guys that don't have the spring in here do it with the entire head assembly. But that's about all I can say. Next, you know, I wish, like I think I've said in one video, I wish I could lock this on 1 degree increments, but you can't. There were 2 of them that it doesn't lock on. 10, I think 60. Yeah, 60 it won't lock on. And I think it was like 130 degrees. Where is it? No, there's one. Oh, no. One of these up here. 210. Yeah, 210 it won't lock on. But, and then it locks on the other weird numbers, which I'm sure there's a reason for it. I just don't know what it is yet. So, well, I hope you enjoyed the video, guys.